So today I'm going to be proving the identity that 1 plus hyperbolic tan x over 1 minus hyperbolic tan x is equal to e to the 2x. Alright, so some things to know before we prove this is that hyperbolic sine x is equal to e to the x minus e to the negative x over 2. Hyperbolic cosine x is e to the x plus e to the minus x over 2. And tan x is, of course, sine x, hyperbolic sine x over hyperbolic cosine x. And it's the same as the just the regular trigonometric functions. Alright, so we begin with plugging in what we know. So tan x, hyperbolic tan x is e to the x minus e to the negative x over e to the x plus e to the minus x. And that's all over 1 minus the same thing. The same thing. Okay? Now, it could get confusing looking at it like this, and my recommendation is that anytime you have fractions, it's best to just combine fractions. So this 1 is the same thing as 1 over 1. If we get common denominators for both the numerator and the denominator, we'll come out with something like this. Okay, over let's see, minus e to the x minus e to the negative x, right? Because when you get the common denominator, these common denominators are going to be equal to each other, so then they just cancel out. So when you get the top, this is the numerator, e to the x, it would be e to the x plus e to the x over e to the x plus e to the x. And so you'll just have that over e to the x plus e to the negative x. Similarly, on the bottom, when you multiply by 1 being e to the x plus e to the negative x, you'll have this as the numerator and e to the x plus e to the minus x as the denominator. You'll have like denominators, so the denominators cancel out once you simplify that. And then a couple other things cancel out. You notice that e to the negative x minus e to the negative x, those cancel out. And on the bottom, e to the x, a negative times a positive is going to be a negative. So these two will cancel out. And you'll have something that looks like this. Negative times a positive, this is going to be positive, so you're going to have 2 of the e to the negative x's left. Alright? And if you can't see it, maybe leave a comment and I'll add some extra notes in there. Okay? And so you have like bases. So when you have like bases, this becomes e to the x. Well, you have like you have two things, right? You have two e to the x's. So you're going to have 2e to the x's, right? Over how many e to the negative x's do you have? Well, you have 2 of those as well. 2e to the negative x's. And if you notice, these 2's cancel. And you're left with e to the x. Now, what is e to the negative x? Well, if we want to make that exponent positive, we just flip it, put it in the denominator, and it'll become positive. So that's equal to 1 over e to the x. And you could even turn the numerator, if you needed to, into e to the negative x. It doesn't matter. This is all algebra at this point. So if you e to the x is the same thing as e to the x over 1 over this, right? So e to the x is the same thing as e to the x over 1. And when you're dividing by a fraction, you can simply multiply by its reciprocal. And there you have it. So when you're combining at the very end, looks like the only thing that's left is over here we were adding. So we get 2 of e to the x's and 2 of e to the negative x. Right here now we're multiplying. We're multiplying, right? So what are we going to do? We're going to keep the same base and the exponents will be added. You have 2 x's. So same thing over here, you have 2e to the x's. So what are you going to get? You're going to get e, and you get 2 x's. All right? And there you have it. We've proved it. Q, E, D. Hopefully that was helpful. Try it yourself, and good luck.